Well, thank you. Here's what we're going to do today. I'm going to give you an equation, a polynomial. I'm going to give you a polynomial, and we're going to see if we can find what the factors are. Let's start with something nice and simple. The function f of x, which we also know is y, equals x squared minus x minus 2. And what we've been talking about lately is being able to factor this. And one of the reasons we would factor it is to find the x-intercepts. You know, if y is 0, where am I crossing that axis? And one of the things we need to do is learn how to take care of these. And these guys were usually pretty easy. Okay, they were pretty easy when I just had a quadratic. But if I had a cube or a quartic or a quintic or I don't know, I'm just making some of these words up. You know, how can I go about factoring this? Well, we learned in last class that we have these things called zeros that are actually my x-intercept. And I wanted to be able to find a 0, and I had 2 ways to find a 0. One was I did division, and we learned that we have long division, and we had synthetic division. And if I could find something that had a remainder of 0, pow, that's also my, yeah, okay. So, you know, I could factor this, and maybe some of you already did. And we learned synthetic division works pretty quick. And synthetic division was a matter of going 1, -1, -2. Well, now I'd like to be able to find a number to put in here, so that bad boy ends up being 0. Okay, so we're tying all this x-intercept zeros together. We did long division or synthetic, and then we also did, and we didn't really care to do long division, we also did something called the remainder theorem, which again was, if I picked an x value and plugged it in and got 0, that was the same as doing this. So I'm looking to get a 0. Somebody, give me a number and we'll see if it works. Pick a number, small number, don't do 48. 48's not going to work, I don't think. Small number, what do you have?
2.
2. So if I plug in 2, my synthetic division went 1, 2, -1, -2. Nope. 2 is eliminated. 2, you're out. Oh, I have to erase. Squiggle, 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 squiggle. Good try. But we only have a few, well, yeah, we have a lot of integers to go making guesses here. We have a whole lot of integers to make. Somebody guess another number.
4.
4. We're going to try 4. 4. 1, 4, -4, -4. You're out. Uh-oh. My eraser is about shot. So that means I can't erase. I need a better guess. Somebody pick a number that might work. Just any old guess. I was gonna say, let's do Wordle. It's 3 letters.
1.
1. We're gonna try 1, and I go 1, 1, 1. That's what I said a minute ago. And that's 0. And that's, oh crap, 1 didn't work either. 1 didn't work either. What if I, well, I set you up with a 1 because there's another number that could possibly work that's 3 letters, but it has another word in front of it. What about -1? Goodness gracious, I keep guessing, and I don't know if they're good guesses or not, but you know, a -1, hopefully you're practicing this and you're going 1, -1, Oh boy, -2, and woo, yes, 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 yeah. So I found -1. So that means one of my factors is x minus -1, which is x plus 1. What's my other factor? Right there it is. This is the remainder. This is the constant term. And this is the x, 1x. Ah, how about that? What do you think about that? So that means my zeros were actually at -1 and +2. At -1 and +2. So I'm going like this and I'm going like this. I don't know why I had that one there. I was just trying to trick you. Again, the remainder, if I would have plugged -1 in for x, my remainder theorem should work the same way. -1 squared is 1 minus -1. That's a +1, 1's 2. Yep, my remainder says that point exists because my y value is the remainder. So that's all the stuff we did the other day. It all sort of tied together. My thing is, I need to figure out ways to factor this. And we had guesses. Some of them were pretty good. We didn't want to go too big, because this is all 1s and 2s, but we went until we found one, and then that's what was left. That's what happens when I divided x plus 1 into that. Okay, are we done? No. What if I gave you this bad boy? F of x. Oh, can't see it, can you? Come over here. Here we go. F of x equals 4x cubed minus 13x squared. Oh boy, minus 32x minus 15. Okay, so this is a cube. So I know that this is going to factor into 3 things. I know it's going to factor into 3 things. I just have to figure out what those 3 things are. All right, so here's what we have today. And there's the equation I just wrote down. I know it's going to factor into 3 things. And I need to, okay, so I'm going to do this. Yes, I'm going to get my synthetic division ready. I'm going to say 4, -13, -32, and -15. And again, the remainder theorem would work, but I don't think I want to plug numbers in here. And that's a lot of calculations using the remainder theorem. So I think I'm going to opt out of that, and I'm going to take a look at this. All right. Well, there's a whole bunch of stuff up here, and it says apply the rational zero theorem. And you're going, more big words and da, da, da. Well, the rational, I'm going to break this down. Rational starts with ratio. It's a ratio. It's a ratio. Okay. Zero theorem means I want this number to end up being a 0. So I'm going to look at some rationals that are going to help me get this 0. I call these good guesses. What's about to happen is we're going to find some good guesses that we can put here to go through this to try and see if we can factor this. Okay, let's see what we got. My good guesses are the combination of P over Q. P over Q. P is the factors of the constant term. So for mine, I'm going to look at the constant term. That's -15. Its factors are plus or minus 1, 3, 5. Oh, that's a 5, and 15. Q is going to become the factors of the leading coefficient. In this problem, the leading coefficient is 4. So Q is going to be plus or minus 1, 2, or 4. Now, this is a lot of good guesses. And this question says just list them all. So let's see what they are. They're going to be plus or minus. P is my numerator. That's the factors of the constant term. Q is the denominator, factors of the coefficient. So I'm going to have 1 over 1, 3 over 1, 5 over 1, 15 over 1, 1 over 2, 3 over 2, 5 over 2, 15 over 2. Now I'm going to write all these over 4. 1 over 4, 3 over 4, 5 over 4, and 15 over 4. So these are numbers that, if any work, it's going to fall into this category. Now that's, like I said, that's a lot. That's 4 times 3, because I put each one of these over this, which is 12. And then I have the plus or minus version. There's 24 guesses to put into this bad boy. Yeah, let's move on to the next one. The question said, list all possible rational zeros. There they are. These are my rational zeros, possible. These are my good guesses to stick over here. All right, number 2. That looks a little better. I'm going to write it out to get ready to do my synthetic division. I have my coefficients 2, 1, -5, -1, and 3. I'm hoping to get a 0 down there. I now need to come up with my good guesses. Again, P is going to be plus or minus the factors of the constant term, which are 1 and 3. Q is going to be the factors of the leading coefficient, which are 1 and 2. And now I'm going to do all the combinations, plus or minus 1 over 1, which we know is just 1, 3 over 1, which is just 3, 1 over 2, and 3 over 2. Yeah, so I'm going to clean this up. Plus or minus 1, plus or minus 3, 1/2 or 3/2. So like earlier, we were just doing some random guessing because we didn't know what to put in. Well, now we're going to try to be a little bit more educated about it and pick these numbers and see where they lead us. So I'm going pencil. I want this to be a 0. First number we're going to try, the easiest one is 1. 1, 2, 2, 3, 3, -2, -2, -3, and -3. Woohoo! Yes. So what is it I've just accomplished? I took x minus my c, x minus 1. I basically divided it into that, and I'm left with, here's -3, -2x, 3x squared, 2x cubed. So I factored it. Yeah, but I didn't completely factor it. I can keep going. So this is already done, which means I'm done with this big boy up here. Now I'm going to do factoring on that guy. 2, 3, -2, -3. All right. Again, if I look at my possible factors, I do the factors of the constant term. They're my p's, the factor. So I can use the same list that I had up above. And again, I'm trying to get this to be 0. Anybody have a guess? Is it possible 1 would work again? Nina, shake your head up and down because you're the only one I can see. She said yes. Let's try 1 again. 2, 2, 5, 5, because I'm just multiplying by 1. 3, 3. Yes. So now I have my first x minus 1. I have this x minus 1, and I'm left with plus 3, 5x, 2x squared. Now, I'm down to a point where that's awesome. I found these first two, and I'm going to say, I'm not going to do synthetic division again. I'm going to take a quadratic, because this is something I know how to do, I think. And I'm going to say, okay, I know it has to be 2x and x. So learning how to factor all these quadratics way back in math, previous math class to this, we're now going to apply it here. I'm still leading the charge on this first one. Factors of 3, looks like if I put a plus 3 here and a plus 1 there, pow! I found the 4 factors. 1, 1. This guy is actually negative 3/2. That's actually negative 3/2. Again, if I set this equal to 0, x would equal 1. So one of my, yeah, x equals 1, x equals 1, x equals negative 3/2, x equals negative 1. So what we're saying here is I could have tried negative 1 up top, and it would have given me a 0. I could have tried negative 3/2 up top, and it would have given me 0. No, for real? Really? Yeah. Show us. Okay, I will. Had I chosen 3/2, which was one of my good guesses over here, and I plugged that into this synthetic division when I first started, 2, 1, negative 5, negative 1, 3. I know this bad boy's going to end up being a 0. Shut up. No, for real. Really? Yeah. All right, I'm doing it in pen, so there's no erase, there's no going back. This is 2. I need you to help me, or you do it. You do it. Work with those fractions.
The next one be 3.
3/2 times 2. Yep. I'll do the add. That's 4. That's going to be 3 times 4 is 12 over 2. 12/2 is of 6. Add. See, again, we're building on something, this synthetic division, that we've learned it and we're using the heck out of it. But it's a procedural, step-by-step process to be able to put all these pieces together. All right, I went long enough. I'm going to say, I think that is 3/2. Ah, sugar. Daggone it. Nuts. What should I put up here instead of 3/2?
Negative 3/2.
Zena, why didn't you tell me earlier? That's a negative 3. Oh, I should have done it in pencil. If I add, I get a negative 2. If I multiply by negative 3/2, the negatives cancel, the 2's cancel. This is a 3. Because the megafunga yavans are evil, but negative 2. 3. 2. Negative 3. And if I add those, I get 0. All right, so fractions actually work. Negative numbers actually work. Yeah, it's all good. All right. I'm going to pause the recording because I'm going to give you a couple minutes to find your good guesses and then see, plug certain ones in and see if you can find one that works. Because if you find one, then you're down to a quadratic already, and you can go ahead and factor. So I'm going to pause it. Cool. I found the factors of P, my constant term. So it's plus or minus 1 and 5. My factors of Q, leading coefficient is just 1. So it's plus or minus 1. The rational zero theorem, which I call good guesses, plus or minus 1, plus or minus 5. Now, it's possible none of those work, and we'll see that later. But I'm pretty sure at least one of them is going to work. And I'm going to do it in pencil, just in case. I know a quick one. I'm going to do f of 1 because my remainder theorem, right, works the same. If that equals 0, that means my y value is 0. If I plug 1 into here, I can move pretty quick with 1 because this becomes 1 minus 2 minus 14 minus 5. So for my guesses, I've just eliminated 1 because that doesn't add up to equal 0. Just took care of 1. I used the remainder theorem because it works quickly for me with 1. That's kind of nice. Actually, not too bad with -1 either if I wanted to. Give me a number that works.
5.
5. 5. Add, then multiply. Add, then multiply. Add, then multiply. And I go whoop, whoop. So this now says 5 is a factor. My C is 5, so it's x minus C. And then this guy becomes no remainder, a 1, a 3x, and an x squared. X squared plus 3x plus 1. Very nice. Very nice. So there's going to be 2 more. There's going to be 2 more zeros. And boy, oh boy, oh boy. Can anybody factor this? Can anybody factor this? Somebody say, yes, we can. You can? Yes. How? Enlighten us. I will. If I can't factor, I think I learned that x is going to equal, negative b plus or minus the square root b squared minus 4ac all over 2a. Really? Yeah. Oh, yeah. Look how much fun this is. Time's flying by. We just, boom, half an hour just flew by. It's amazing how fast this class goes. X equals, no, -3 plus or minus. I'm a math magician, so I'm going to say that this is, and I'm actually writing it down here. B squared is 9 minus 4 times a times c, which is 4. That gives me 5. Square root of 5 all over 2. That's it. There's my other 2. There's my other 2. Are they numbers? Yep. I could ask the Google, what is -3 plus the square root of 5 divided by 2? And it's going to be a number like -0.482. It's an actual number. It's nothing imaginary about this. But my roots are going to be that. And I should have done this. Comma 5. 3 places it crosses the x-intercept. I'd have to do some calculating on that. But here's 2 of them. Here's the third one. The degree was 3, so I know there's 3. So again, we're tying in something else we've learned from way back. Wordle. What is b squared minus 4ac called? 10 letters. Little quickie review. What was my b squared minus 4ac called? 10 letters. Give me a D. Give me an I. Give me an S.
Distance.
No, this wasn't the distance.
I thought it was a quadratic formula.
It's this b squared right inside of here.
Oh, the discriminant, or whatever that's called.
Discriminant, yeah, discriminant. Yeah, it was called the discriminant. And that told me some things. If it was positive, there were 2 roots. If it was 0, there was 1. If it was negative, there were 2 imaginary roots. That was my floaty graph. So, wow, look at all those words. Please put it in your own words for us. I will. Let's move down here. Oh, if 1 minus 5i is a factor, is a 0, it says find the remaining factors. Oh, well, here's something. I know that x minus 1 minus 5i is a root, is a factor, right? If I said 3 is a 0, it would be x minus 3. If I said 5 is a 0, it would be x minus 5. Okay, so we're tying all this together. Well, one thing that happens because of this b squared minus 4, blah, 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 there's always a plus or minus. So it's like the, what is it, the Sith. If there's 1 minus 5i, there's always another. And its conjugate would be the 1 plus 5i. So if this is 1 minus 5i is a 0, then 1 plus 5i has to be a 0. Okay. X minus 1 plus 5i is a 0. I don't know what the third one is, but I know what these two are right away. Still going to have to figure out what the third one is, but oh, so here we go. The conjugate zero theorem says if a plus bi is a 0, then a minus bi is a 0. That's right. That's what we just did. If a minus bi is a 0, a plus bi is a 0. Okay. So we probably should multiply these together. You should do it in pencil, sir, because you keep screwing up today. I know. First thing I'm going to do is distribute these negative signs. X minus 1 plus 5i. X minus 1 minus 5i. Don't panic, because this should come out pretty. I am going to triple distribute. I'm going to take x times everything over there. I'm going to take -1 times everything over there. And I'm going to take 5i times everything over there. All right, so I get x squared minus x minus 5ix minus minus x plus 1 plus 5i, and then finally plus 5ix minus 5i minus 25i squared. It's good we learned how to work with the I squareds. Aye, Captain. That was pretty bad, SpongeBob. Who lives in a
Pineapple.
thank you, under this. All right, so here's what I have. I have my x squared. Boom. There weren't any other x squareds. I have minus, I took care of that. I have minus x and minus x, okay? Minus 2x. I have negative 5ix and positive 5ix. See you later, alligator. I already took care of this. I have a 1. And this guy, actually, that becomes negative 1. So this guy should turn into plus 25. So I have a 1 and a plus 25, which gives me 26. And I have a 5i and a minus 5. Son of a gun, it did turn into something nice. Attaboy. That-a-boy. So I found the first two factors, and I need to still find the third one. Oh boy. I could do good guesses, right? And plug in 1, 2, 13, 26. Something along those lines. I do know there's going to be 3 zeros because this says the number of zeros of a polynomial, if it's greater than 1, then there's 1 0 or there's n zeros. We already knew that. There's 3 of them. We already took care of that. It just has an official name. I need to find that last one. It's not lost. I know. I need to calculate, discover what it is. Ah, ha. I want to find the third one. I can do this. I can divide this into x cubed minus 3x squared plus 28x minus 26. How can you do that, you say? How can you do that, you say? Okay. So if I have a number, it's a mystery number. 196. And I say, okay, I know 2 divides into that, right? And 4. And I probably screwed this up. But if I wanted to find the next number that gives me 196, couldn't I just take these 2 and divide it into 196? If I know 2 things that divide into it, I know that I could say, well, what's that third thing? Well, take these 2 and divide it into it. You can get it. Long division. Long division. All right, I got this. You got this. You got this. What times x squared gives me x cubed? That's just an x. So I get x cubed minus 2x squared plus 26x. Subtract is the same as add the opposite. See you later. Negative x squared plus 2x minus 26. What times x squared gives me negative x squared? That's negative 1. Negative x squared plus 2x. Where did I mess up? Plus 2x minus 26, negative 1, positive 2, negative 20. That's not right. So it tells me I did mess up somewhere. Oh, man. X cubed minus 3x squared plus 28x minus, I copied the problem down, right? Hopefully I did all this right. X, negative x squared, negative x, negative 5xi. Good. Negative x plus 1 plus 5i plus 5ix minus 5i minus 25i squared, which becomes plus, gives me a plus. Somebody find where I messed up yet? Oh, I didn't mess up. Subtract. That's the same as add the opposites. Yeah. Ooh, yeah, 0. So my third factor is right here, x minus 1. These guys multiply together to give me, these three guys multiply together to give me that. Wow, that's a lot of work. If you like numbers, this is great. If you see no use for it, it really makes it hard. But I did a great job of explaining it, just saying. Shaka Khan, everybody good? Yeah, yeah, yeah. All right. Oh, now they call it a solution. Given that x equals negative half is one solution, find the remaining solutions. Ooh. Number 6, find a polynomial of lowest degrees with zeros 3i and 2 with a multiplicity of 2. I'm gonna help. I'm gonna help get it just started. All right, I know one of them is negative 1/2. I have 2, negative 1, 17, negative 9, and negative 9. And I know I'm going to get an answer. I know this is one of my roots. But then I need to figure out after this one what the next 3 are, because there's going to be 3 more of them. This guy, find a polynomial of lowest degree with zeros. There's an imaginary one, 3i, x minus 3i, which means what else is going to be 1?
Plus 3i.
X plus 3i. And now it says, and 2, but it has a multiplicity of 2. What that means is it occurs twice. It occurs twice. All right. I talked a lot. You need to talk to each other. I'm going to pause the recording. All right, let's check it out. See what I have for number 5. I know negative 1/2 worked. 2 times negative 1/2. Negative 2 times negative 1/2. 18 times negative 1/2. Negative 18 times negative 1/2, 0. Good. What was I left with? 2x cubed minus 2x squared plus 18x minus 18. Now, I'm going to keep going with this, and then we're going to come back to this, and I'm going to show you something else. So now I want to factor this guy, 2x cubed minus 2x squared plus 18x minus 18. I took a guess of 1, and because I saw a pattern here, 2, negative 2, 18, negative 18. Boom, 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 boom. 1 worked. I went, woohoo. So now I had 2 factors. X minus negative 1/2, which becomes x plus 1/2. X minus 1. So I had 2 of them. Now, what was I left with down here? 2x squared minus 18. You notice I pulled the 2 out. I'm left with x squared minus 9. And that factors into 2 times x plus 3 times x minus 3. Here's the x plus or x minus 1, and here's the x plus 1/2. So I factored it completely. I'm like, yeah, sounds good. Now, one of the things I could have done up here is divided everything by 2, which means I'm pulling 2 out. because it would be a factor. So I'm pulling the 2 out and it ends up coming out over here, but I could have pulled that out early and added it to my list if I wanted to. Questions on number 5? Okay, good. Hopefully you were active in your groups and you got to work with each other a little bit. I didn't come around and check. Sometimes I hit random group, but you know, 3x minus 3i, boom. X minus negative 3i becomes x plus 3i. Again, this was x minus negative 3i, because if 3i is a root, negative 3i is a root. X minus 2 with multiplicity of 2. Multiplying these first two together, I double distribute. X squared plus 3ix minus 3ix minus 9i squared, which I know becomes a plus 9. These two cancel, so this just gives me x squared plus 9. These two you've done a million times. X squared minus 4x plus 4. So now I'm going to double distribute. I have two things here that I want to distribute to there. So I take x squared times each of these and 9 times each of these. Combining like terms, I get a final answer of x to the 4th minus 4x cubed plus 13x minus 36x plus 36. Cool. I'm going to change my view to gallery so I can see. Thumbs up. How many got both of them? Thumbs up. Thumbs up. Okay. Thumbs up. How many got one out of the two? All right. There's a couple. Thanks, Jess. Thanks, Nina. Thanks, Kaylin. All right. So some of you were able to get one out of the two. Thumbs down if you have no idea what we're doing. Is there a reaction? Thumbs down. Okay, Daniel's waving his thumb around like he put his thumb in the pudding or whatever that is. You were caught with your thumb in the pudding? Yeah, okay. All right, I'm going back to speaker view. Again, we finish up today. Don't wait a week and a half to do the homework because you're going to forget so much. And then you have to watch this video all over again and hear all my dingy comments that I make. Find a polynomial with degree 3. That means there's going to be 3 factors. 3, it's going to be a cube. Zeros are negative 2i. So then I know it's x minus negative 2i, x minus 2i, and 4. Okay, so I have those 3. The polynomial must also, we'll look at that in a second. We'll look at that in a second. Boom. X plus 2i, x minus 2i, x minus 4. Okay, I'm going to try this. Think I got it. Squared minus 2ix. I don't want to be saying too loud that you could just be writing down as I say it.
Why is it -4 at the end?
I don't know. What should it be? 16?
Yeah.
Because I wanted to see who's paying attention. Nice job. Okay. So if I did this, what are my roots? If I just look at this, what are my roots? 2 and -1. So I have a graph. Here's 2, here's -1. My graph looks something like this. Okay. If I added a 2 here, would I still have the same intercepts? Yeah, this guy would just go 1 and like everything would be double. So I could have 2 graphs that have those same. I could have, another graph. Another graph. I could have lots and lots and lots of graphs that have 2 and -1 as their roots. And what changes all those is the number that's out in front. And if you remember, that number out in front ties into my amplitude. So that number always exists. Usually it's 1. But for our problem, it throws this extra, satisfy the condition P of 0 equals 32. So if I put in 0, f of 0, I get 0 minus 0 plus 0 minus 16. So right now, f of 0 is minus 16, which means, yes, there is something in front of all of this. Minus 4x squared plus 4x minus 16. What would I have to multiply by? And I have to multiply everything. What would my a be out front so that when I plug 0 in, I get positive 32 instead of negative 16? What number?
I think 2.
Negative 2. Excellent. Excellent. So we have that out there. Again, I still have the same 3 factors, but the negative 2 satisfies this condition. Okay. And we had a positive 2 up here, and that's okay. And that's okay. All right. Is there any more? Yes. We're in the home stretch. Yes. Yes. All right. This next guy, we are not doing this. Okay. We are not finding upper and lower bounds, but we're going to learn how to do Descartes' rule of signs. Now, what if I gave you this and you do your good guesses and you're, oh my gosh, there are so many good guesses. It's not even funny. Okay. There are so many good guesses. 1, 322, 160, 480, and I could keep listing them. And that's just because the P, remember it's P over Q to do my good guesses, is just a crazy number. But what if I could give you another hint and said, when you do find the actual answers, the roots, the zeros, the x-intercepts, remember we have all these meaning the same thing. The roots, the zeros, the x-intercepts, and this was even brought up the other day. How they all, there you go, how they all mean the same thing. Well, this fellow Descartes' rule of signs, Descartes says this: if I go through this original equation and I count the sign changes, okay, it's in here. The sign changes for f of x, that's going to tell me the number of possible positive roots. All right, what do you mean by that? So for my positives, I'm looking at this. I go from plus to minus. That's one sign change. Minus to minus, no. Minus to plus, that's my second sign change. Plus to minus, that's my third sign change. And minus to plus, that's my fourth. So for the number of positive roots, there could be 4 of them. And the special thing about this is it comes in pairs. So there could be 4, there could be 2, or there could be none. Not like the greatest help of all, but he's saying there could be 4, there could be 2, there could be none. Now negatives. Negatives come from if I do f of negative x into my equation. So if I did this guy, I get negative x to the 5th minus negative x to the 4th minus 14 times negative x cubed. Oh, going downhill now. Plus 32 times negative 1, or excuse me, negative x squared minus 176 times negative x plus 320. Goodness gracious. Cleaning it up. Negative times and have 5 times, that's going to give me a negative x to the 5th. That's going to give me minus x to the 4th, because that'll return it back to being positive. This will give me a negative, so that'll be a plus 14x cubed. This is going to stay plus 32x. This guy changes to 176x, and that stays as 320. So now I'm going to find my negatives, again, by the sign changes. Negative to a negative, no. Negative to a positive, yes. That's 1, no, no, no. So this is now telling me there is, in fact, one negative real root. So that means in my graph, over here in the negative, it's crossing somewhere. Over on the positives, it could cross 0, it could cross twice, or it could cross 4 times. All right, so number of positive roots, 4, 2, or 0. Number of negative roots, 1, 1, or 1. How many roots are there altogether? Well, I know there's 5. So I could possibly have positives, I could possibly have negatives, or I could have those with imaginaries. And folks, this is a loaded day today. This was a big day. So if there's a total of 5, that means there would be no, so this is one possibility. 4 positives, a negative, and no imaginary. My second choice, I know that has to equal 5. So if there's 2 positive and 1 negative, it's going to be possible there's 2 imaginary. Now, we know imaginary always comes in pairs. That's why we did 4, 2, and 0. And my third possible combination, there are no positives, there's 1 negative, and there are no, or excuse me, 4 imaginary zeros. That's coming out of that negative b plus or minus the square root of the discriminant all over 2a. And we're going to have to practice, do 1 or 2 more of those. But I think that'll be something good to start with Tuesday after spring break. Lots and lots and lots of stuff today. Fortunately, you have notes. You have a video if you need to go back and watch it. Are there any questions?